Welcome all for today's session on CI/CD for deep learning, automating deployment. So here, deep learning models are powerful, but deploying them is very complex task. Here comes the challenges for deploying the deep learning models, like manual deployment will take huge time, inconsistent environments will be there, lack of monitoring, hard to retrain that model automatically. So here the solution to this is we can use our CI/CD pipelines for machine learning or deep learning models for ensuring the reproducibility, automation and scalability of that particular model. So today we will do a deep understanding about this. We will have our architecture diagram on CI/CD for deep learning and also we'll do the hands-on on this. So here, this is our CI/CD pipeline, wherein the first stage here is data pipeline. So in data pipeline, we will have a data source. So data source, which can be in a CSV format, CSV file formats, which can be in a databases or which can be in a streaming data as well. So this raw data will undergo pre-processing using different libraries. Okay, pre-processing libraries. After we will clean this pre-processing, cleans the data, handling missing values, convert them into some formats, and prepares the feature suitable for training data. We can use your NumPy, Pandas libraries for pre-processing as well. So this step will ensure that our models get quality data, which is critical for our performance. After this, the second stage is our model development. So the clean data feeds into our training pipeline where machine learning models or deep learning models are created. Typically done with the frameworks like scikit-learn, TensorFlow, PyTorch framework. If we are using machine learning, we will use scikit-learn. If we are using deep learning, we can use a PyTorch or we can use a TensorFlow framework. Okay. The model will learn pattern from training data. For example, classifying any like flowers or classifying any objects or predicting any class within the images. If there is a 2-class classification, if there is a 3-class classification, if our data is nothing but a image data or whatever, the data can be in any format. After training, the model is saved to text and optionally it will be pushed to model registry, such as machine learning flow for version controls and governance. Okay, so this will allow tracking experiments and managing the different model versions securely. We will have a CI/CD pipeline. In our CI/CD pipeline, we will do a continuous integration and continuous deployment automation process will be there. When new code or models are ready, the CI pipeline builds a container image using Dockers. It will include the model artifacts and the fast GPA server code. This container image is then pushed into the container registry for secure storage. Using rule-based access control only like RBAC, or we can have a different like RBAC will do what? It will only authorize users and system which can access for deploy container images. Okay, once we will give any features of this particular image or particular thing, it will generate and it will predict the outcome. The CD deployment or the CD component, there are two components, CI and CD. CI will do what? It will make it into some Docker based image format. The CD component will deploy these image into a Kubernetes cluster. Okay, this will ensure automated, repeatable and reliable production deployment. So CI is nothing but it will make a Docker into a Docker based image or it will deploy container images within the Dockers, and CD component will deploy these images what has been generated by CI into a Kubernetes clusters. Okay. So after this, there will be a deployment and operations. In deployments and operations, we can models whatever has been served as REST API endpoints, running as a container on Kubernetes or Kubernetes managed pods or scaling or load balancing or service discovery. Here we can also use Grafana or ELT stacks monitors these services, which will track the uptime, latency, system metrics, logs, and user interactions as well. This operational visibility helps detect issues, optimize the performance, and triggers alert when it is necessary. Okay. So after this, we will have a continuous feedback loop here. Okay. Here we can also have this logs functions. Okay, which can be accessible for any like admin based or any type. Then there is a feedback loop. The deployed service collects user interaction, metrics, and logs continuously. It will do. The data is feed back into the system for monitoring and retraining the triggers. So new or misclassified data is there. Okay. So annotation will help them refine this model again. Okay. The continuous feedback loop will improve the model accuracy and business values over time, which will ensure that the machine learning solution stays relevant and effective as well. Okay, so here we have understood about there are first is our data pipeline wherein the data will be in the form of any like databases. In the database format, our data set will be there. Once we'll fetch that data, what we will do? We will do a data pre-processing. We'll clean the data. We will do a model building part. Once the model is ready, we can use it for CI/CD pipeline. We'll convert that model into some image. Okay, into some image-based container format, which will be done in RBAC, in CI pipeline. Okay, and then we will have this container-based approach, which will take this image and it will use it for deployment part in Kubernetes. Okay, so CI components will deploy these images into Kubernetes clusters, and the annotated or repeatable or whatever the reliability productions, it will be there. Whatever the deployment it will be do, it will be a production ready deployment. Then we will have our deployment and operation part wherein continuously monitoring all these things will be done. And hence we are going to deploy this model on Kubernetes. Okay, so likewise, a continuous approach will be done here. Then we will have a feedback loop continuously doing the same task like annotations, log, retraining, matrix, or user data. Whether it is in line to whatever we have trained here or continuously improvement will be done here. Okay, so this is what our CI/CD pipeline deployment. Then let's take one look on our code. So here I have taken this particular data set, which is a flower data set, which is an open source data set. So first this machine learning pipeline is here. I have taken this data set from GitHub directly, and this data set is directly available in our open source data set. This is nothing but a AiSPRY data set. This is available in GitHub. This is available in Kaggle. Okay, you can easily get this data set from open source platform. Okay, this AiSPRY data set is nothing but it will have three classes of flower. Okay, so by looking at the species means what are the different species it belongs to. The species are of three type. Okay, so three class classification model is this. Okay, so we have trained this particular model. Okay, by using logistic regression, and we have saved this particular model in model.pickle format. So this is our model here, model.pickle. So here our focus is not on model training, but our focus is mostly on deployment part. So we have taken a very easy data set here. Okay, we have saved this model in model.pickle. So model has been saved here. Okay, once the model is saved, we will use the serve model.py file, wherein we will have our fast API endpoints. Okay, so we'll check that whether this model is running in Kubernetes or not. So this is the thing. Then here there is one more term called as a Docker file, all these things. So first you have to have the Docker environment. or Docker desktop in your local machine. Okay. So here we will firstly in this ML.pipeline. Here what we have done, we have load our data, train the classifier and save that particular model. Once that is done, we have used this particular served model, which will load the data models, which is your model.tickle format, which is this model only. Okay. And this will do what? This will expose it to fast API endpoints for real-time classification requests. You can use it instead of this. You can use Postman for checking whether the model is running fine or not. Okay. So you can use Swagger also for checking the model is running fine or not. Firstly, we will have all this requirement files also. Okay. So this is our requirement file. We have to install all these dependencies. And after that, there will be a Dockerizations. So this is nothing but your Docker file. So this is the Docker file. This is the Docker file. And here all the requirements, all these things, and the model itself, which is a serve model, which is this serve model, which we have used for fast API endpoints, which we are using here. Okay. And we are using a port of 8000. Okay. So here the Docker file package will do what? It will take the Python app and model into a portable container image. So this will do what? This will create, once you will run this, this will do what? It will make this into an image format. Okay, so I have run this. It will take huge time to run this. Like it has taken huge time to run this particularly. Once this is run, it will make into some image format. Okay, so you can see the MyFast API app is latest, which is this, which is 1.64, 1.62 GB. At that time, it was 3 minutes ago. Okay, so once this is done, you can use the Kubernetes deployment, which is a YAML file over here. Okay, here all this thing is there. Okay, what port, okay, what are the different versions, all these things. This is nothing but a template which we generally use for like a Streamlet we have. Now we are deploying in a Kubernetes format. Okay, so YAML file will deploy the container. What container? Your Docker container. Okay, which will expose the API as a service with load balancing and making it accessible inside or outside the clusters. Then what you can do, you can test your API using Swagger or curl commands, okay, and sending the flower features and giving the predictions. So let's see, let's do this once. Here I have already done this. This is our Swagger. Okay, this endpoint will be working. Okay, this endpoint was working. I have given some random features in our predict. Once we'll go in the predict and reset it, you can give some sample features like which is there in your RSD dataset, like sepal length, sepal width, likewise petal length, petal width. You have given something, and based upon this length and width function, what it will do? It will do a prediction which class it belongs to. So here you can see it is giving a prediction that it is a Setosa. So this is a class name. Okay, and also when you want to run this in your locally, if you want to run it, when you will run this, you can see this without Swagger. If you want to see it, it will give you command called ARIS classification API is running in Kubernetes. Likewise, and also the third way you can do means you can use your whatever the features you have given right now here, like sepal length, sepal width, petal length, petal width. Likewise, you can give in your command prompt as well. Okay, you can search for this. You can give the sepal length this much, sepal width this much, petal length, petal width, all these things. And it will give you a prediction at this is a class of Setosa. Okay, likewise, there are multiple other classes also. You can just change this and you can see the variations in a prediction class. Okay, so likewise, your deployment file or a Docker file will also run here. You can see. Here you can see this is my Docker file which is right now running on. Okay. Let me once just open this. You can see this Docker file here, which is 2 hours ago, which is running right now here. Okay. This is the first one. This is the 2 hour ago one, which is my fast API, this one. Okay. Once you will click this, this is also working on all the endpoints, everything you can see here. Okay. So this is nothing but your one demo related to, or one hands-on related to how you can actually train your model using training is one part. You can do a training part. After training, how you can deploy that particular model by using containers. Okay, so we have used this Dockers as a container, and we can deploy this model using Kubernetes also. Okay, so I hope it was informative. Today's webinar was informative. So this is our contact details, guys. If you are interested to join our session, you can contact us. And this is our mail ID. Our salesperson will call you back. Okay. Thank you, guys. Thank you for joining. We'll meet you in the next lecture with new topic. Thank you so much.